We now move into the enhanced synchronization circuit, which consists of three components: a frame counter, a decoding circuit, and a control finite state machine. The frame counter and decoding circuits are exactly as the ones we've seen when we developed the hardware VGA controller. The frame counter, its main purpose is actually to generate X and Y. So it's basically just two modular counters, and it's exactly the same as the global frame counter. It's the same code. The decoding circuit in here, what it does, it takes the X and Y and generates the H syncs, the V sync, and the video on, similar to what we've seen when we developed the VGA controller. Now the control state machine, or the control finite state machine in here, is what's new, and that's why it is a little bit on the enhanced side. So before we talk about what it's doing, let's see what it actually can read. So the input to this particular control FSM is actually the local X and Y from the frame counter. It also gets a signal which we call it start. It actually indicates that the start, basically the pixel 00 is actually in the line buffer waiting, basically the very first line in a frame. So basically the beginning of a new frame. So that actually it knows the beginning of a new frame. It also knows an SO valid, which is basically the signal that it signals that the line buffer or the FIFO is not empty. That means there are certain pixel information that are useful. It also basically takes as an input, which is a clock. It's actually the pixel clock rate. So it operates at the 25 megahertz in here. It has a single output, and that output is in here, and its purpose is actually to go to the line buffer or the FIFO buffer and tell it like the serial output is ready. Basically move on and read that pixel data and move the pointer, move the pointer, and move the pointer of the FIFO. So this is what the control FSM can read and write. So its main purpose is actually twofold. So the first one is actually when you're actually displaying something on the screen, you know that the frame counter and the decoding circuits are generating the H sync and the V sync. What you really need is you need to provide it with a red, green, and blue for the VGA. So what's it doing? It's actually, you have that particular stage, or it's actually a state. It's a physical state that is basically going to it goes to the line buffer, it reads some sort of a pixel data and just basically move on. And then the frame counter moves and it reads the next one. And then frame counter moves and then the next one and so forth. So basically it helps basically send synchronization signals and send pixel data in sync with the frame counter and the H sync and the V sync. Now, the second thing that it does, it actually synchronizes this frame counter with a global frame counter. So this frame counter cannot stop and should not be stopped, okay, because it's actually controlling the H sync and the V sync with the VGA. And the other frame counter in here might be operating at, well, it is operating at a different frequency. This is actually operating probably at the 100 megahertz. This is at the 25 megahertz. And because of that, we know that the FIFO actually slows things down because it stores everything. But because of that, you need to make sure that the beginning of a frame in here is the same as the beginning of a frame in here. And the control machine or the finite state machine will help us do this. So let's see how it's actually implemented, and maybe we'll understand how it's actually going to do that. So the finite state machine is actually two-state. There's actually the display state. This is actually when you're actually displaying something on the screen, you are within the viewable area on the screen. And the frame sync, it actually helps me sync so that I have the frame counter here is at the very beginning, and the line stored in here is actually the beginning of a new frame. So let's see how this is actually implemented, and it'll help us understand the frame sync state. So here's the code for that, and the code is, again, what it has basically these for the decoding signals, similar to what we've seen before. And then we have an instance of we instantiate a frame counter, and then this is how the decoding circuit is worked. What's new is actually this finite state machine in here. So with the finite state machine in here is basically have these state register. Really, this is what's new in the code. So what's new in the code is I have a couple of states. I have the frame sync, and I have the default one, which is basically the display. Let's start with the display since it's easier. So in the display, what's it doing? It's telling me, well, if it is at the very end of the viewable area, these x equals HD minus 1 and so forth, these HD and VD are basically the VGA resolution, the 640 and the 480. So it's telling me, like, if you're at the very end, the next state is the frame sync. So let's worry about this later. But for now, it's telling me if you are within the viewable area, basically just assert the VGA serial in ready. Basically just go and assert this particular signal and read the next value and read the next value and read the next value. That's what's doing as long as you're in the display state. That's what's doing. you leave the display state into the frame synchronization state where when you actually reach the very end of a frame. So you have shown all the frames, and at the very end basically you're going through the left border and the bottom border and you're doing the retrace, and that's basically when you go to the frame sync and you actually wait till the retrace happens, till the very last end, which is the vertical retrace, the one that goes back to 0 0, and you just basically stay in here while it's actually doing all of that. That's the purpose of this state. So let's see what the frame sync is doing. Well, the frame sync is actually doing a couple of things, or actually testing. There's a couple of if statements. There's one in here and there's one in here. These are the major ones. So the first one tells me if the scan end is generated by the frame counter in here. It's actually read into it. It tells me basically the very end of the frame. Basically, you have finished all the X and Y's within the viewable areas. You actually reach the very end and then you retrace. This is basically when the scanned end actually is issued. So when the scan end is issued, the frames, the control machine is going also to the line buffer and it's going to ask, is the new line that I have in here is a new line? Because remember, it's like if after a frame sync, for example, you went in here, basically that's done. So you're here, you are expecting to see on the line buffer a new line from a new buffer. So the start signal should be asserted, okay, it should be 1, and now I'm trying to read it. So I'm asking, did it finish the retrace, the vertical retrace in here? Is the line buffer, does it contain a new line from a new frame? If that's the case, then yes, then the next step would be, okay, then you have to go and basically go to the display state, and these are basically when you leave the frame synchronization and actually move to the display state, and it will start displaying things. Okay, now the more interesting thing is actually, this is why I wanted to take a look at the code and explain it in here. It actually, here's the deal. So let's assume that you actually went and you displayed everything, and then you went through the retrace, and now you're back in here, and the control state, basically you went to the frame sync, and now you want to go back to the display, but you're going to the line buffer, and for some reason the line you have there is not the very first line. Basically, for some reason you got in here, and that's where it got stuck. So you got out of sync. You are at the beginning, basically you're like the scanning in here, that part of the system is actually telling you, okay, I'm going to send a new frame to the VGA monitor. However, the line in here does not contain the very first row of a new frame. So what we need to do is, there's some sort of a corrupted, maybe something happened with the start signal in here. We don't know, but there are multiple reasons why this might happen. So what we're going to do is, this particular signal actually does something really interesting. It actually flushes that particular line buffer. So it will assert that signal and keep reading it, keep reading it, keep reading it. So keep reading it, keep reading it, keep reading it until it actually flushes all of it, and then it gets back in sync and everything goes back to normal. And that's basically what's it doing. So it's gonna get stuck in here till that particular signal get asserted, and then, well, the frame counter is not gonna stop. Okay, so if the frame counter is not going to stop. So if you have a new line in here from a new buffer, it's going to also wait for the frame counter to actually finish all the way to go back. So when these two conditions are actually met, which is basically you're at the scan end actually when you do the retrace, and line buffer also have the information for the very first line. That's basically when you move to the display and you start displaying. So it actually does some sort of a synchronization, and that's why we call it an enhanced synchronization circuit, because it does this flushing and make sure that basically the frame counter in here is synced with the other global frame counter.